In the name of Allah, the most gracious, the most merciful. Good morning, everyone. Now we are going to deal with our new program for mathematics department in Tabarak Private School with you, teacher Muhammad Al-Badri, with grade 11 mathematics teachers, and we are going to deal with the lesson of the sum to infinity. And before anything, we have to say big thanks for the chairman, Mr. Yunus Al-Rahbi. Now we are going to start with our new lesson, the sum to infinite.
How are you, my dear students? I am Mr. Muhammad Al-Badri, teaching grade 11 bilingual. Welcome to our private school, Tabarak. From our educational platform, we have to thank our chairman, Mr. Yunus Al-Rahbi, who gives us this wonderful opportunity to contact with our dear students. The arithmetic series. For any arithmetic series, we have number of terms: first term, second term, third term, fourth term, until you reach to the last term. And if we want to find the relationship between the arithmetic series, we have to know the arithmetic series has very important property. It's about the difference between any two consecutive terms is the same. The difference means what? We have to subtract t2 minus t1, second term minus first term. We will have the same value if we subtract the third term minus the second term, the same value if we subtract fourth term minus third term. So the general formula for the arithmetic series: Tn equals a plus n minus 1 times d, where a is the first term, n is the order of the term, and d is the common difference between any two consecutive terms. So d equals Tn plus 1 minus Tn. And to know how could we apply this rule, we have exercise 8a, page 133, number 2. For the given sequence, find the values of the fifth term, the sixth term, and the seventh term using the formula Tn equals a plus n minus 1 times d, and the sequence is 11 plus 16 plus 21 plus 26. The answer here, to start it, we have to find the first term, which is a equals 11, and the common difference, which is 16 minus 11 equals 5, or 21 minus 16 equals 5, or 26 minus 21 equals 5. So here we have an arithmetic sequence because we have the same difference between any two consecutive terms. Now the value of the fifth term equals a plus 5 minus 1 times d. Why 5 minus 1? Because the order of the term is the fifth term. So n equals 5 becomes a plus 4d, and the value of a is 11. The value of d equals 5. So 11 plus 4 times 5 equals to 11 plus 20 equals 31. So the value of the fifth term is 31. And now for the sixth term, the same steps. Here we will have it a plus 6 minus 1 times d. So the value of a is 11, the value of d is 5. We are going to substitute it. Becomes a plus 5d. Now the value of a 11 plus 5 times 5, it will be the value of sixth term equals 36. And now the seventh term, a plus 7 minus 1 times d, a plus 6d, and the value of a 11 plus 6 times 5, the value of the seventh term becomes 41. And now for the next exercise, which we have it here, exercise 11, page 140. Find the number of the terms of the arithmetic series. The number of the terms here means what? Is it a? Is it d? Is it l? No, it is n. So we have to find the value of n. So we have a equals 67, d equals 57 minus 62 equals negative 5, or 62 minus 67 equals negative 5, and the value of the last term is negative 13. Now if we have the last term, that means we have the answer key. Do we have here the last term? Yeah, we have the last term, negative 13. So negative 13 is the answer key, so we have to use it using the general formula. L equals a plus n minus 1 times d, which is the last term, so negative 13 equals 67 plus n minus 1 times negative 5. By simplifying here, negative 5 times the brackets, each term inside brackets n minus 1, it will be negative 5n plus 5, and 67 plus 5 equals 72. Move it to the other side by solving a linear equation, so we will have negative 85. So now here we have n equals 17 after dividing each term here by negative 5. So the number of the terms here is 17 terms, starting from the first term 67 till you reach to the last term negative 13. We will have 17 terms. Now here we have a new exercise in the arithmetic sequence 95, 92, 89. Find the value of the sixth term, the order of the term whose value is 68, the order of the first negative term, the order of the first term whose value is less than 25. To find it, firstly we have to know the value of the first term. It's easy now, it's 95, and the value of the common difference 92 minus 95 is negative 3. To find the sixth term, T6 equals a plus n minus 1, 6 minus 1 times d, and the value of a is 95 and the value of d is negative 3. So T6 equals a plus 5d, 95 plus 5 times negative 3, it will be 80. So the value of the sixth term is 80. Now the second equation, the order of the term whose value is 68. To find the order of the term, that means we are asking about the value of n. So the value is 68, a is 95, d is negative 3. So n here we want to find it. So how could we find it? By substituting each variable a, t, and d, and by simplifying we will have 68 equals 98 minus 3, so 3n equal to 30, so n equals to 10. Now for the third, the order of the first negative term, which is 95 plus n minus 1 times negative 3, that we have it, the order of the first negative term means less than 0. So less than 0 here means we have to make it as an inequality and solve it like a linear inequality here. So 98 minus 3n less than 0. So 98 less than 3n divided by 3. So n is greater than 32.6. What is the integral greater than 32.6? It will be n equals 33. So the 33rd term is the first negative term. And now for the last question in this exercise, the order of the first term whose value is less than 25. The order is the same here. We have to find the value of n, but we are going to make it less than 25. So it will be 95 plus n minus 1 times negative 3 less than 25. By simplifying, we will have it 98 minus 3n less than 25 becomes 73 less than 3n divided by 3. So n greater than 73 divided by 3. So n greater than 24.3. What is the number greater than 24.3? It is 25. For this exercise, very important to know how could we find the order of the term. Now for the next exercise here, find the arithmetic series in which its third term is 11 and its seventh term is 47. So here we don't have anything except the values of the terms, the value of the third term and the value of the seventh term. To find them, we have to know the general formula. So the general formula for the third term is a plus 2d and the value equals 11. So here we have equation 1, and the seventh term a plus 6d equals 47. So here we have equation 2. Now we are going to solve them simultaneously. So equation 2 minus equation 1, we will have it a minus a equal to 0, 6d minus 2d equals 4d, and 47 minus 11 equals 36. Now divide each term by 4, we will have d equals 9. How could we find a now? By substitute d equals 9 into equation 1 or equation 2, we will have the same value. So here we have a plus 2 times 9 equals 11. So a plus 18 equals 11. So a equals 11 minus 18 equals to negative 7. So the series starting from the first term negative 7, and each term we will have to increase it by the previous term by 9. So the first term negative 7, the second term negative 7 plus 9 equals 2, the third term equals 2 plus 9 equals 11, and so on. Here for the first lessons. Now we have a new idea about how could we find the sum of n terms of an arithmetic series. For any arithmetic series, the sum of n terms of an arithmetic series whose first term is a and its common difference is d can be found by two formulas. The first one, sum of n terms equals n over 2 times 2a plus n minus 1 times d, or sum of n terms equals n over 2 times a plus l. So what is the difference between the first formula and the second formula? The first formula, we can use it if we have the value of the number of the terms, the value of the first term, the value of the common difference. But the second formula, we can use it only if we have the value of first term and the value of the last term and the number of the terms. Okay, it is not necessary to find the difference, the common difference between the terms. And to know how could we apply it, here we have exercise 8D number 3, page 143. Find the sum of terms of the series 2, 7, 12 till you reach to the last term 77. So here we have the last term, so it will be easy to find the sum. Why? Because we have a equals 2, d equals 5, and the last term is 77. But how could we find n? We said it before, if we have the last term, it is an important answer key to find the number of the terms. So from the last term 77, we are going to find the order of the last term, which is the same time the number of the terms, starting from the first term 2. So 2 plus n minus 1 times 5 equals 77. It will be 5n minus 3, by simplifying it equals 77. So 5n equals 80, and divide each term by 5, so n equals 16. Now we have a equals 2, we have l equals 77, we have n equals 16. By substituting each letter by its values, so we will have it sum of 16th term equals 16 divided by 2 times 2 plus 77. Put it in your calculator, you will have the sum of all of the terms starting from the first term 2 to the last term 77 equals 632. Now for the last exercise in our lesson of arithmetic series, exercise 8D, page 144, number 5B. Find, teacher, what this sample? This sample is the sum. Find the sum of the terms starting from the first term, which is 1, till you reach to the sixth term, which is 6. We have it here using the relation 3r plus 2. Teacher, how could we know if we have arithmetic series or geometric series? It depends on the relation we have. The relation here has r and r here from the first degree. That means we have arithmetic series. If we have it power 2, power 3, power 4, it is not arithmetic series. So here 3r plus 2 is a relation from the first degree. That means we have an arithmetic series. So to know how could we find it now, we have to find the number of the terms. The number of the terms is 6 minus 1 plus 1. If we have different numbers, instead of 1 is 2 and instead of 6 is 10, if we want to find the number of the terms, it will be 10 minus 2 plus 1. So plus 1 here, we have to use it each time. So the number of the term is 6, and the value of the first term is a value when we substitute r with 1. So 3 times 1 plus 2 equals 5, and the last term, the value when we substitute the value of r with 6. So 3 times 6 plus 2 equals 20. Now the sum of 6 terms equals 6 over 2 times 5 plus 20. Put it in your calculator, you will have the sum of the 70. The sum is 75 for this question. So now here I hope to make good lesson for you, and I hope you understand it, and I want to thank you for your listening, and see you in next lesson, and goodbye.
Thank you for listening for our explaining, and I hope you enjoy with us. And the homework, you can find it in the model and in your contact number in the WhatsApp and on the model. Thank you very much.